Not too many difficulties. My career path was probably a little different than a lot of people. I guess I was no more than 3 or 4 years old, and I knew I was going to be in broadcasting. I had witnessed listening to a radio broadcast with somebody in New York, and I was more than halfway across the country. And my little 3-year-old mind said, gee, this is incredible. I'm hearing this person in New York City down here in Arkansas. I need to find out how this is possible. So that was the twig, the way the twig was bent, so to speak. And I became very interested in electronics and radio. By the time I was in the 5th grade of school, I had built a pirate transmitter. We operated, my friends and I operated a pirate radio station on weekends and after school. And a few years later, when I got to our junior high school, that's the 7th or 8th grade of education, the manager of the local station found out about me and made me an offer I couldn't refuse. He said, I want to employ you running my station on weekends. So I had to get a license from the FCC, the regulatory body, and here I was at not quite 14 years old, and I'm running a complete radio station all by myself on weekends. So I continued to do this, working part-time in radio as I went through my high school years. I did the same thing in college until we got our first television station in that part of the state, and I got a job in television, working part-time till I graduated from college, and then I stayed with it. And I did this for nearly 37 years working in television engineering. Again, learning as I went. There are only so many things you can learn in an engineering curriculum at school. So a lot of the learning I did, like most people in the profession, in the engineering side, it was hands-on. They don't teach you too much about satellite dishes and tuning transmitters and things like this. So I continued with this for, like I say, almost 37 years. I did the last 20 of those almost exclusively designing facilities, studio facilities, control rooms, transmission centers. I went all over the world, literally, working with our team in implementing satellite downlinks and some uplinks in places. So I decided I'd had enough after almost 37 years, and I retired. And 3 weeks later, I started a second career as a journalist, as an editor for a national magazine, TVTechnology magazine. And even though I'm not working full-time, I did that almost 8 years. I'm still not working full-time now, but I am working for the magazine. I do write for them, do deliver several stories a month for them, and also other magazines. In addition, I am the editor-in-chief of the magazine that you're holding there, the publication. We're not supposed to say magazine, because it doesn't fit a legal definition, I think. But a publication we do that I'm very proud to work on, to put together for the IEEE's Broadcast Technology Society. Our publication, as you can see there, is called Broadcast Technology. And I try to make it very readable, to make it interesting without having to use too many brain cells. It's what I call techno-light. We have a lot of human interest type stories, a lot of light papers without a lot of graphs and charts. As I said, triple integrals, this sort of thing. So that's my story. That's my career in broadcasting. It's taken me a lot of places. It's taken me a lot of places I never expected to go in my life, and I'm still working in it, even though not working on the engineering side per se. I am reporting about the technologies, the new emerging technologies, and what is going on in engineering. Well, I see a lot of promise with the new emerging digital TV systems, the hybrid TV systems, utilizing both the internet and over-the-air transmission. I see a lot of promise there. If we can make this work, we can get people to adopt it. I see a lot of promise in other modalities involving digital technology, such as we had 2 presentations today involving all digital radio, FM or VHF radio. It's hard to say it's FM when it's really digital. It's in what we call the FM band, but VHF. So well, let's say VHF digital, and let's say medium wave digital for AM. I see some promise there, and at least in the U.S., radio does need a lot of help. It is having some serious problems. Maybe you've read about these. But I'm hoping this will bring more listeners in and revitalize, both AM and FM broadcasting. If I may use those terms, they're pretty much entrenched in me. It's hard for me to say digital medium wave and digital VHF, but you know where I'm coming from. So what else can I tell you? Artificial intelligence, okay. Yeah, it's very interesting and it's very frightening at the same time. I think it has a lot of potential, but I look at the other side of the coin, as they say, and I see it putting a lot of people out of jobs. I see it possibly even getting out of hand. We have machines that are thinking, they're thinking faster than we are. Who knows, there could be a revolt of the machines. But the good side of it is it takes people out of mundane, what we say, humdrum jobs where they're just basically filing things, assigning numbers to things. They could be much more productive, utilize their minds, their skills, their capabilities, and much better, but not doing these mundane jobs. So I do see a good place for artificial intelligence there. But again, who knows where it's going to take us. I read science fiction. I'm very much of a science fiction fan, and I've read some stories which don't have good outcomes when the machines take over, when the artificial intelligence, so to speak, becomes dominant and the human species becomes subdominant. Replace? Oh yes, that's what I was saying. I think it, even now in the next few years, it has the potential to replace people doing these mundane jobs and let them do something, a little bit more creative. But I don't know where it's going to go. We're talking about driverless cars. That is an implementation of artificial intelligence. We are seeing actual, autonomous vehicles, driverless cars today. And I see if that really takes off, that has some very profound changes on our society, on our economy, and every other way. When you think of jobs it would eliminate, think about this. In a large city, if you had autonomous vehicles at your beck and call, all you did was take your smartphone and punch in a code, the car would come to your apartment, your flat, and you would not need to own a vehicle. The cars would be circulating all the time, 24/7. You wouldn't need parking garages. The parking garages in big cities could be converted to parks, playgrounds. Again, the parking attendants are out. You wouldn't have as many accidents. That would cut the number of emergency medical technicians you might need at a hospital. That would cut the number of people repairing the cars. And because the cars are not driven by humans, they're driven by computers, by artificial intelligence, probably the cars would last a lot longer without needing repairs. So this one little sector, autonomous vehicles, relying on artificial intelligence, could have some very profound changes in our economy and our social structure. Well, I said this, this was almost 35 years ago. I saw two things shaping up, two paths. This was back in the late 1970s. And I said, I think I need to learn as much about computers as I can and as much about satellite technology as I can, because this is a coming thing. Well, the computers, most engineers didn't like computers at first. Now there is, it was pointed out in a presentation or two earlier today, computers are ubiquitous. We live with computers. They do a lot of things in broadcast operations. So I think a person who wants a career in broadcasting needs to learn a lot about computer technology. We're talking moving from conventional SDI, conventional infrastructures for building a radio or a television station. We're moving to IP technology. I think a person really needs to learn a lot about that. That may not be the easiest thing to do. I don't know that colleges are teaching courses in IP connectivity, but this sort of comes along with knowledge of computers and data networks and creating data networks. So these are essential skills. One of the areas which is sadly lacking as we move further into this 21st century, in broadcast operations, there are not that many people that understand the transmission end of the business, how transmitters work, antennas, transmission lines, things of this nature. There's a very short supply of people that are qualified to work on transmitters, even though the transmitters have become much easier to work on, much safer to work on, the voltages are much lower, but still you need to understand something about radio frequency transmission, and perhaps this could be part of a curriculum for a person who wanted to get into this end of broadcasting. But I'm looking strictly at the technical aspects of broadcasting. I mean, we're talking too about lighting a studio. We're talking about building, constructing sets for television shows. I don't think we need to go there. This is more of an artistic thing than anything else. But engineering skills, yes. Very strong computer, very strong IP skills. And if you want to specialize, and there's probably some money to be made there because there's so few people that are capable of doing radio frequency work, transmitter work, you should think about following some sort of a curriculum or doing some sort of a study that would put you in a good place to work with RF transmission equipment. Wish something? Well, I wish we had more people. Well, I wish we, if I had to make a wish, I would wish for simpler times, because it was so easy when I was a young person, a person in just a few years of my life, to take a few bits and pieces of things, some headphones, a variable capacitor, some wire, a crystal diode, and make a radio receiver. Very simple, but you can't do that now, or you won't be able to do that with digital radio. It won't work. You can't. It's too complex. So I sort of wish for simpler times. It was easy, or a lot easier, let's put it that way, when I was working my way into the profession, to figure out how signals flowed, how a camera operated, how the tube in the camera worked, how a valve or vacuum tube, or as you say, electronic lamp operated, how components fit together. And now nobody goes down to that level. Everything is done on a chip, and you've got very specialized people who design these chips. And we're talking now virtual machines, where you have basically a computer and you program it to do whatever you want it to do within the broadcasting environment. You don't need specialized equipment like we did when I was coming along. So it would be easier to understand how broadcasting works if times were simpler, but they're not, and we can't go back. So again, I wish the best for anybody who wants to follow this career. It's been a very rewarding career for me, and I certainly wish them a lot of luck in following a career and a path in broadcasting.